No, no, sir, no, sir. I'm really sorry.
Okay, so what's your question?
I don't.
What's your question? Just be clear on your question.
Is the chi-square like what? Like how did you get the interpretation?
Okay, yeah. So I know you guys have not done lectures yet. I think it's tomorrow if I'm right. That will be done by someone else. But were you at the last class with what did the difference in means with continuous variables?
Yes, yes.
Okay. Now you recall that these are tests of associations, right?
Yeah.
Yeah. So here we are now looking at the chi-square test looks at categorical variables, while the t-test looks at continuous variables, right? Now we are trying to our null hypothesis is that there is no association between being married, being female, and being married. Now, in this particular test group, there was no difference between male and female with respect to marital status, right? Do you understand?
Yeah, yeah.
And as the marital status of the males were not different significantly from, significantly from the marital status of the females. That's our null hypothesis. And we now, to test the hypothesis, we performed the chi-square test. And we found that there was, we got a p-value of 0.160, which is greater than 0.05, right? So yeah. What does that, what was the implication of that on our null hypothesis?
So we accept the null hypothesis.
Okay, yeah. To reject. Yeah, so we fail to reject. We don't yeah, we don't use the term accept the null hypothesis, right? Because but what we have found is that we don't have sufficient evidence to reject the null hypothesis. So we fail to reject it. Right? So the purpose of our test was to find out whether we would be able to get evidence to reject the null hypothesis. But from our test, there is no significant evidence to reject our null. So that's it. Any further queries or confusions?
Hello, sir.
Yes.
Okay, you said our focus would be on this Pearson's chi-square. So, and I guess is this on this row is the asymptotic significance that,
yes.
That is 0.160.
Yes.
Which is
that's two-sided, yeah.
Which is greater than our alpha, I guess, of
yes.
0.05. That's why we said this is not significant, not statistically significant. Yes. And that's why we fail to reject the null hypothesis.
Yes.
It is just this one, so no other way.
Yeah, the screen is no more visible to us. I don't know, so there's a shade on it. I don't know what's causing that. Okay, beautiful. It's clear now. Okay.
Oh, now, yeah.
Yeah. So that's what we are doing now, the chi-square test. Let me throw in a freebie, which is not part of the practice today, but I will just share that. Now, when you look underneath, you can see where they wrote A, 0 cells, 0% have expected count less than 5. Do you see that?
Yeah, I can see it. I can see it.
Yeah. So if we had ticked expected value in our when we're doing the crosstabs, you'll see that that there was no cell that had any value that was less than 5. Right, in the expected count. Now, when you have that, when you have anything less than 25% of cells being less than 5, right? So now if one, it's a 4x4, it's a 2x2 table, so there are 4 boxes, right? So if at least one of the boxes in the expected is less than, has a value of less than 5, we will not use the chi-square test. We're going to use the Fisher's exact test. So how you're going to know in this is just to look at the percentages down there. If it is greater than 25%, then you use the Fisher's exact test, which you can see right there, right? But in this particular case, we use the chi-square test because it's less than, we have 0 cells that are less than 25%.
Yes, I didn't get that, sir.
Yeah, so if that percentage there under A, if it is 25, if it is greater than 25, if it's maybe 30 something, expected that that is less than 5. So it tells that 0 cells have expected values less than 5. This is not part of the lectures for today, but I just want to throw in that freebie. Yeah. Okay, let me share my screen and do this. It's easier to share than to. Can you stop sharing?
Can I stop sharing?
Yes.
Okay.
Please. Share screen. Okay. Right. So analyze, descriptive, cross-tab. You have it all there. Statistics. We want our chi-square. Okay. I think I did. Oh, sorry, not that. I did. I need to untick this. And let me tick this. Expected. Someone had asked about that before, right? So let's see what's going to happen, right? So, okay. Yeah. So we have this again. And you can see that our table is a bit more complicated than before. We now have, so we have our expected value here, right? Can you see that expected count? Hello?
Yes, sir.
Yes, I can
Yeah, so
see.
we
Yes,
now have 2 counts. We have the count, which is the observed count, and we have the expected count. Now, when you look at the expected, now remember this is a 2x2 table, so we have there are 4 boxes, right? 1, 2, 3, and 4, right? In the expected count, we have 41, 69, 19, and 32, right? Those are the 4 boxes. Now, when you have a situation whereby at least one of them is less than, has a value of less than 5, you can't run the chi-square test. You have to run a Fisher's exact test. But you don't need, previously, I recall when I was still at the university and we were doing chi-square tests, we were doing it manually, we calculate with our calculator and all that. We'll draw this 2x2 table, and then we'll now look at the 4 of them. We didn't have a software to use at that time. We didn't use the software. So we would look at the 4 tables. We'll look at the 4 tables. And if there's anyone less than 5, we know that we can't use a chi-square test. But thanks to SPSS, you don't need to create an expected count. Hello? Who is talking? So thanks to software like SPSS, we don't need to calculate your expected count. It tells you already once you run your chi-square test whether there's anyone that is less than 5. Right? So it tells you here 0 cells, that there's no cell with an expected count less than 5. Is that clear? I didn't see any confusion. Now I mentioned 25% because 4 boxes, 1/4 is 25%, right? And I said if there's at least 1 box that has a count less than 5. So if the figure down here is this 0% is greater than 25, then you use a Fisher's exact test. Is that clear? Everyone is confused. Don't worry.
Yes,
Sorry?
Yes, sir.
It's clear. Okay, thank God it's clear.
No,
But
it's not clear. Oh.
Well, maybe when you do the lecture, so it's not part of today's lecture. I just brought it as a freebie, so let's not waste time
Things
on
we are
that.
going well. All of a sudden, you
25
now
or
mention
if it's more than
25%
20%,
again.
sir.
Don't worry about it.
I'm worried, sir. Please. Sir.
No, don't be worried at all. Because I mean, if you're worried, you'll be worried about whether Putin is attacking Ukraine, which is not affecting you right now.
Chief, I'm worried though because I was getting you until you mentioned another 25%. I say,
remember, I counted now. How many? Now, this is a 2x2 table. A 2x2 table has how many cells?
It has 4 cells.
Now, 4 over 4 times 100 is what?
4 over 4 times 100 is 100.
So 1 over 4 times 100 is what?
1 over 4 times 25.
Good. And we said if at least one of the 4 cells has a value of less than 5. So that's where our 25% comes from.
Okay, if it has a value less than 5, you don't run a chi-square test, right?
Yes. So that's why all these two-range that I'm talking right now shouldn't have. I think I'm not who went to look for trouble. Once you just see that percentage is greater than 25, you use the feature as that test. Make it that. I was trying to explain why, but the why is becoming complicated. So just know that as a rule of thumb, once you have anything, that percentage under there written, anything that is greater than 25, use the features as that test for your interpretation.
Okay, sir.
Are we happy? Are we happy now?
Let's move on, sir. Thank you.
Maybe I believe it probably will be taught tomorrow in your lectures, I guess. So maybe during the lecture session, you have enough time to ask those questions.
Thank
I think it should be clearer by the next lecture, so we can ask questions afterwards.
Yeah. So I know that this now today's lecture is an anomaly. We are doing the practice session before you receive the actual lectures, so that's why there's a bit of confusion, right? But when you now have so unlike previous session where you had the lectures first, so when we are now run the practicals, you had an understanding of what we're doing. Yeah. So yeah, so we move on to, there's an assignment there. Let me share my screen. So that someone will do that assignment, or you guys will do that assignment. Everyone who has, okay. So this gives us a very practical understanding of how the chi-square, what the chi-square does, right? So it says you are a statistician on a trial of testosterone to treat low libido among postmenopausal women not taking estrogen. 811 eligible women were randomized to receive testosterone, 300 micrograms, and testosterone 150 micrograms, or placebo. The variable testosterone identifies women who received testosterone and those who did not. Right? So the variable in the data you're going to analyze now is binary in nature. Binary, it has 2 options. Those who received and those who did not. Some women attained menopause as a result of surgical procedures and can be identified with the surgical menopause variable. Right? So the instruction here is that you should import the menopause CSV file and then use that menopause CSV data set, create a 2x2 table, and you're going to run a chi-square test to assess the relationship between surgical menopause and testosterone levels. Right? So who wants to run that?
I think I should do that. I'm going.
Okay, so let me stop sharing. So this just gives, it's still the same thing I've been doing, but just gives a practical, a real world scenario to it. So once we're done with this one, we'll go to more interesting things. I hope we can add, and the more interesting things are very, very interesting. So I hope that we have time because time is running fast away. Okay, great. So, okay, you've already imported the data. Okay, good. So, can you run the test?
Yes, but I've not actually been able to know which one is a dependent or independent variable here. But it's like it's the surgical menopause as the dependent variable. I'm not.
So okay, go ahead.
Analyze descriptive.
Mm-hmm.
Cross tabulation.
Mm-hmm.
Surgical menopause should be on the column, and the testosterone.
Let me see what the question is. So
let me look at the question. Yeah. I can't read the question from here because my screen is set.
Okay. Okay. So let me. You have it on the setup, so you can actually read it there.
Okay.
Yeah, I think I'm looking at this because the question is saying that some women they randomized. Okay, so they randomized 811 women to receive testosterone or placebo. So that is your
and even the testosterone is of different milligram, I think.
Yeah, but in the data set it's not. They didn't separate that.
Okay. Yeah. Okay. So they now want us to compare those of surgical menopause.
Yeah. So surgical menopause is what? An outcome, isn't it?
Yes, sir.
Because the randomization was based on receiving testosterone or placebo. So your exposure variable is testosterone and your outcome variable is surgical menopause.
Okay. So I've done that. Then I'll go to statistics.
Okay.
Select chi-square.
Okay.
And continue.
Yeah.
Cells, do I need to put the row percentage?
If you want to.
Okay. And then let me continue.
Who's making us dance?
Someone is disturbing it.
Yeah, with music. Can you?
Okay. Then okay. So let me stop and share my output. Okay, this is the output.
Okay. What's that?
I think I made no statistics are computed because surgical menopause is a constant. Sorry, it's like we didn't actually get the association here. I don't think it's
okay. So let me see.
Let me go back. Let me
go back and check.
I think you made a mistake. I have a result here on my own end.
Okay.
Yeah, I think you made a mistake.
You can share your screen.
Okay. I think there's an error somewhere because even if you switch the variables, it is still going to give you the same result. Just that the 2x2 table, the same chi-square result will come up, but the 2x2 table will be different. Yeah. So who wants to share this? Who is sharing the screen?
Okay. Can I share my screen?
Yes, please.
Okay.
I would also want to see where he went wrong, but Hugh share screen first. Let's see. I was surprised to see that outcome.
Can you see my screen?
No, yeah. So go through the process, step by step.
Go through the process. Okay,
yeah.
Let me go back. Sorry. Stop share. Okay, so analyze. Analyze descriptive statistics, first tabs. Okay, so surgical menopause on the road and statistics.
Okay, I think this is where I got it wrong. The surgical menopause is on the row. Mine was on the column.
Continue.
Yeah, but that shouldn't. Okay.
So hello, I think there might be two different data at play here. Like, I'm saying this data is different from the one the first person shared and worked with.
So this is because so I mean, if you swap the exposure and outcome, it shouldn't give you a different chi-square statistic. So that's why I'm surprised. So I think it's probably a different data set. Yeah. So go ahead with this one that is right. I think there seems to be a mix of the data set that was shared with you guys. So yeah, you can continue. Who's sharing? Emeka, right?
Okay. Yes. So these are my results.
No, we are not seeing your results. We are seeing your data.
I think it's my data set.
Because irrespective of how you swap your exposure and outcome on for your chi-square, it's going to give you the same result. The only difference will be your 2x2 table, which may be slightly different because in the way you now interpret it, but the chi-square test will still be the same. So that's why I was surprised. Okay, so Emeka, go ahead. Share your other screen.
Okay, wait. Let me start sharing.
I'll communicate to them that some data sets are inaccurate.
But sir, can we look at this data set closely? I don't think there is. I mean, like the question goes, there might be some issue. I don't know. It just seems confusing to me because the treatment is just there's just a column of 0, 0, 0, all through.
Yeah, zeros means that intervention was not given, or and 1 means the intervention was given. Right? It's a binary variable.
Yeah, but what is that trying to say is that nobody actually received an intervention of.
Oh, okay. You mean that particular data set has 0 everywhere? No, there was no 1 at all.
Yeah, exactly.
Okay, yeah. So that's what I'm saying. That one data set is wrong. So we are now sharing the right one. This what Emeka is sharing is the correct data set. So if you use data set that is in my Dropbox that I shared with you, you would have the correct data set. Yeah, so obviously, we've seen 2 different data sets right now that have had some challenges. So that means the data sets shared with you recently we are not the right data set. I would communicate with the team so that it doesn't happen again. Yeah, so use the one that is in my Dropbox for now. And that one has the accurate data set. Sorry about that.
All right, sir.
Yeah. So Emeka, can you go ahead?
Okay, can you see my screen now?
Yeah. Okay,
so looking at this table, the chi-square test, we are having 0.514, which is.
Is that correct?
Sir?
Is that correct?
The table, you mean the table?
No, what your chi-square test that you are interpreting.
Is interpreting the Fisher, and there is no.
Yeah, that's Fisher's exactly you're looking at.
Okay, sorry. Yeah, basis chi-square. Yeah,
and it doesn't meet the assumption for Fisher.
Yeah.
Okay, the Python size square. I'm using this rule now,
Okay.
and we have a p-value of 0.513.
Okay. Yes. And so what does that mean?
It's greater than 0.05. So that means we fail to accept. No, we fail to reject. That means there's no statistical significance
between
the surgical menopause and testosterone use.
Okay.
Use of testosterone and surgical menopause.
Yeah. So it means those who received there was no difference between those who received testosterone and those who did not with respect to
surgical menopause.
Having surgical menopause as an outcome. Okay, thank you so much.
Yeah. Hello, sir.
Yep.
I think I flipped it. Rather, the surgical menopause was on my column, while the testosterone was on the row.
Yeah.
So what did I do wrong? Can you put me through? I said, can you put me through? I know you said the column would be for the outcome.
Yeah. So for the chi-square test, if you flip it, okay, Emeka, can you do it and flip it and let's look at what happens?
Okay, sir. Okay, let me stop sharing. I think so. I think it's this one. Okay. Analyze the descriptive.
Crossed up.
Crossed up.
Yeah, you know, everything, just click OK. Okay, so let's see your output.
Yeah.
Let's see your output.
Okay, I'm coming, sir.
Yeah.
Okay. You didn't produce any output, so I'm coming. Maybe I didn't do it, so. Yeah.
The output.
Yeah, I'm trying. I'm coming.
You have you have one.
Wow.
If it's happening, maybe I should try share my own if I can.
Okay, you know what? Because of time, because we just have 30 minutes and we're supposed to go to the regression. Let's stick to our. You can try it when you're at home, but you know this test is testing association between two things, right? The chi-square test, right? So conventionally, your 2x2 table would have what do you call it? So your 2x2 table will have your exposure on the row and your outcome on the column, right? But the test is just trying to see whether there's an association. So if you flip it, you will still have, if it's not significant, it will still not be significant. So that's the point I'm trying to make. I just want to demonstrate.
I got the same answers, but just thank you, sir.
Okay, yeah. So that's it, because it's just a test of association, right? So in a how you look at it, it's still not going to be. It still have the same thing, but the way you interpret it becomes different because you're not looking at your 2x2 table. You're talking about, particularly if you're looking at if you're interpreting according to the rules, right? So conventionally, the row it should be the exposure, and your column should be the outcome. But if you flip it, that would mean that rather than ticking on row for your 2x2, you will tick on column, right? I don't know if that's clear. Okay.
It's clear, sir. It's clear, sir. Thank you.
No problem. Let's not try to analyze how Putin invaded Ukraine. Let's tackle the Boko Haram crisis that is in front of us.
It's all right, sir.
Yeah. All right. So the next thing that we're going to go to look at logistic regression. Let me share my screen. I'll give a little bit of introductory lectures so that you will, but you'll get more of it, I think, tomorrow. Yeah. So we recall we discussed the linear regression the last time, right?